Elena, and I'm doing the chapter 11 video assignment. So part 1 is asking for the moles of, or the molarity of N2 at 1 atmosphere and then at 4 atmospheres. So we have our equation right here. It gives us the K constant, and we know that the partial pressure of N2 in the air is 0.78 atm. So we plug in the constant with the partial pressure of dinitrogen in the air, and that equals 2.964 times 10 to the negative fourth molarity. So then to get it at 4 atmospheres, we do 0.78 partial pressure of nitrogen in 1 atmosphere, but at 4 atmospheres at the depth of the sea, we get 3.1 atm. So we plug 3.1 atm in for our pressure. We have our constant that we multiply it by, and then we get 1.1 times 10 to the negative third molarity of dinitrogen at 100 feet at 4 atm. So next question is asking the volume of dinitrogen in 5 liters going from 4 atm to 1 atm. So we have the moles of dinitrogen, and we multiply that by 5 liters because we're trying to get it in 5 liters. And then that is the number of moles we get. We do the same thing for the moles at 4 atm, multiply it by 5 liters, find the difference between 4 atmospheres and 1 atmosphere, and we get 4.4 times 10 to the negative 3 moles. These are the amount of moles of N2 that escape the blood. So we're looking for volume, so now we can plug our moles into the ideal gas law. And so we have our moles, our constant, 37 degrees Celsius is 310 Kelvin over 1 atm, and then that gives us 0.11924 liters of dinitrogen that escape in 5 liters of blood. So we're looking for how many bubbles formed, or if it escaped in the form of bubbles, how many bubbles would there be? So we're looking for the volume of the sphere because the bubbles will form a sphere, and then it gives us that the bubbles have a 1 millimeter diameter. So the equation for solving for the volume of a sphere requires the radius. So we'll convert our diameter into meters, and then we'll divide the diameter by 2 to get radii. So this is the length of the radii for this bubble, so we'll plug it into the equation, and we'll get that the size of this bubble is 5.235 times 10 to the negative 10th meters cubed. And then we get the volume of the escaped dinitrogen and convert it to meters cubed. And then once we have the volume of dinitrogen that is escaped, we divide that by the size of the bubble to get the number of bubbles in 5 liters, and we divide that by 5 to get the number of bubbles in 1 liter, which is 43,150 bubbles for every 1 liter.